3.4 notes is a review of your imaginary numbers, also called complex. Let's start by the general form of a complex number. A complex number is made of two parts. One of them is the real one, and the other one is the imaginary. The real one is the value that has no I involved, and the imaginary one is the one that has an I involved. You need to remember I is actually the square root of -1, and I squared is equal to -1. I cubed will be I squared times I. That will be -1 times I, which is, or I can write I squared times I, which is -I. And I to the power 4 is actually I squared times I squared, which is equal to -1 times -1. So the final answer is 1. I to the power 5 is I to the power 4 times an extra I, which is actually equal to 1 times I, and it will be I to the power of 6 is, I have many ways of solving this. I can say it's I4 times I squared. I4 being 1, I squared being -1. So that will just be -1. To make your life simple, there are a few things you need to somewhat memorize. This is 1. I squared equals -1. The second one is I cubed is equal to -I. And the last one is I to the power 4 is equal to 1. If you memorize these three, it will make your life very simple. Let's look at the first one. I have the square root of -16. The square root of -16, the simple fact that I have a negative, it means that my answer will have an I involved. But the square root of 16 is 4, so my answer is 4i. Note that I didn't put plus or minus 4i. It is exactly 4i. No plus and minus. The only time you put plus and minus is when you're solving with a variable. So, for the next one, I have square root of -3. To find the square root of -3, the negative will come out as an I, and the square root of 3 cannot be evaluated, so it stays as I square root of 3. 45, you can break 45 into smaller factors. 45 is actually 9 times 5, which is 3 and 3. So a 3 will come out and a 5 will stay. Along with a 3, a negative will come out, giving you 3i square root of 5. Now, number 4 is square root of -2 times square root of -3. I know back in Algebra 2, you heard inside with inside, outside with outside. This is not equals to the square root of 6. Instead, square root of -2 is actually I square root of 2. Square root of -3 is I square root of 3. Now, if you multiply the i's, you get -1. And if you multiply now square root of 2 and square root of 3, you get square root of 6. So your answer is negative square root of 6. Number 5, I have I raised to the power of 23. There are multiple ways of doing this. You can find if you memorize the three stuff that I asked you to memorize earlier, meaning I4, I3, and I squared, you can easily solve this. For I23, I will do it two different ways. You can say I23, 23 is the closest multiple of 4 in 23 is I20 times I to the power of 3. But I20 is actually I to the power of 4 raised to the power of 5 times I raised to the power of 3. Anything that is a multiple of 4 as an exponent will give you 1. So this whole thing is 1, and I cube, as we know, is -I. So your final answer is -I. That's one way of doing it. Another way of doing it will be to say I23 is I times I to the power of 22, which is square whole thing raised to the power of, because if you take one I, you're left with 22. That's 11. Now, I remain I. I squared is negative 1. Negative 1 raised to an odd power is negative 1, giving you again negative I. So it's up to you how you get there. The main important or the most important thing is to get to the right answer. To add or subtract complex number, just mix a real part with the real part and imaginary part with an imaginary part. So this one will be 3 plus 5i. Distribute the negative to get minus 4, but plus 2i. Combining like terms will give me 7 plus, actually, is 7i. And if I have negative 4 and 3, I end up with negative 1. So it's negative 1 plus 7i. On number 7, again, it's a product. You will apply your double distribution if that's how you learn. If you learn how to FOIL it, you go ahead and FOIL it. So it will be 2 times 4 minus I plus 3i times 4 minus I. If you distribute this, you get 8 minus 2i plus 12i plus 3. Actually, it's minus 3i squared, but it will end up being plus 3. So this times this will give you minus 3i squared. But I squared is negative 1. Negative 1 times negative 3 will give you your positive 3. That's how I got this positive 3 here. So from here, I will go ahead and continue by grouping like terms. So if you group like terms here, you get 2i and 12i will combine to give you a total of 10i's. And 8 and 3 will combine to give you a total of 11. So I have 11 plus 10i. All right, let's keep going. Now we do number 8. For number 8, here again is a product. I will do square root of 12 times 3. I can first start by breaking 12. 12 is actually 4 and 3. So it's 2 square root of 3. So I can say this is 2 square root of 3 minus I square root of 3 times 3 plus 2i. I just transformed the square root of negative 4 into 2i and the square root of negative 3 into I square root of 3. And I simplify square root of 12. Now I will use my double distribution. I will use the blue on this one. So I will have 2 square root of 3 that I'm multiplying by 3 plus 2i. And I will also have negative I square root of 3 that I'm multiplying by 3 plus 2i. If you distribute it, that will give you 6 square root of 3 plus 2 times 2 is 4i square root of 3 minus 3i square root of 3, and this one will give you a plus 2 square root of 3 because I squared is negative 1. At this point, I will combine my like terms. I have 6 and 2 giving me a total of 8 square root of 3, and I have 4 square root of 3 and 3 square root of 3 here. 4i and 3i combined to give me a total of 1i square root of 3. So my real one is 8 square root of 3. My imaginary part of the complex number is I square root of 3. For 9 and 10, I want you to rationalize. What do we mean by rationalize? Just like we do with radicals, here we don't want I on the bottom. To get rid of an I on the bottom, you can either multiply top and bottom by 4i, but the easiest way is to multiply the top and bottom just by I here, so that you will get rid of the I on the bottom. So on top, I will end up with 7 times I with 7 will be 7i plus 3i times I will give me 3 times negative 1, so it's minus 3 over 4i times I will give me a negative 4. Well, this is not the normal complex form, so I will rewrite it as negative 3 divided by negative 4 will give me 3/4. 7 over 4 will give me minus 7/4 of an I. Real, imaginary, the whole thing form my complex. So this is my answer. Let's rationalize the next one. To rationalize the next one, I will multiply by the conjugate. The conjugate of the bottom will therefore be 1 plus 2i. And I will do it to the top of as well. On top, you will go ahead and distribute 3 times 1. I will have 3 plus 6i plus 5i, but minus 10. Over on the bottom, I have a plus b, a minus b is a squared minus b squared normally, but instead of a squared minus b squared, it's going to be a squared plus, because the I squared would be negative 1. So I will have 1 plus 4. Let's combine like terms on top. I will end up with negative 7 plus 11i over 5. And I will break it down to get negative 7 over 5 plus 11 over 5i. And that will be your final answer. The last two problems require us to solve. So let's go ahead and solve it. To solve the first one, meaning number 11, I have x squared plus 4 equals 0. It means that x squared is actually equal to negative 4. I find the square root on both sides to get, I will go ahead and apply the square root on both sides. And on the left side, I will have x, but on the right side, because it was a variable, I will have plus or minus 2i. For the next one, I have x squared plus 4x plus 5 equals 0. I will go ahead and use my quadratic formula. In my quadratic formula here, a is equal to 1, b is equal to 4, and c is equal to 5. I will use the formula that says b squared, I will rewrite it, minus 4ac inside the radical, meaning negative b plus or minus over 2a. Well, this one would be negative b would be negative 4 plus or minus square root of b squared would be 16 minus 4 times a here is 1, c is 5 over 2a, meaning 2 times 1. So I will simplify this. This is equal to negative 4 plus or minus square root of 16 minus 20. That will be negative 4 over 2. Well, this is equal to negative 4 plus or minus 2i over 2. Let's simplify. That will be negative 4 divided by 2 and 2 divided by 2. That will give me negative 2 plus or minus I.